Hi, someone asked me to explain 9.1. 9.1 is composite functions and also the algebra of functions. So we're going to do both composite functions and also the algebra of functions. And so, to begin with, I'm going to give you two functions, and you can call them anything: f of x, g of x, h of x. I'll just say if f of x, and I'll give you that, is x plus 3, and g of x, we'll call it g of x. It could be h of x, it can be anything, whatever they choose to name it. But what we're asked to do when we're asked to find the algebra functions is something like this. We're asked to find f plus g of x. Now I'll tell you, that's how they write it in this book now, but they used to write it like this. They used to just say f of x plus g of x, which to me makes a little more sense, because you're just going to add f of x to g of x. But now it looks like this, so keep in mind that that is what this means. So when I tell you to add f of x plus g of x, I just go to f of x, which is x plus 3, and I'm going to add that to g of x, which is 3x minus 1. So combining like terms, I get 4x plus 2. And that's your answer. That's done. F plus g of x is that whole function. That's complete. Let's try f subtract g of x. I guess you would probably guess the common error here, well, like always with subtract, is distributing. So I'm going to go to function f of x, which is my x plus 3, and I'm going to subtract now the whole g of x. So I'm going to put it in parentheses so that I subtract all of it, 3x minus 1. So don't forget, you have to distribute that subtract sign through. Then we're going to go ahead and combine like terms. So I have negative 2x, and then 3 plus 1 is 4. So that's your answer. That is f subtract g of x, that whole function right there. Now if they say f times g of x, now we have to multiply them. So once again, I just go to f of x, x plus 3, and g of x, 3x minus 1, and multiply them, which means in this case to FOIL. So first times the first, outside times the outside, inside times the inside, last times the last. And lastly, just combine like terms. So once again, your function is the answer. That whole equation is f of g of x. Now if they give you a number like this, if they say, suppose they say f plus g of 3. Now, instead of x's, we're going to put a 3 in their place. And you know that. You've done that before. If you had this function and this function, and I told you to find g of 4, you know that you would go to function g, and wherever you see the x, you would plug in a 4. So 3 times 4 subtract 1. We've done that before. So you do the same thing now. Oops, 11. You do the same thing now, but this is your choice. You can do it at the beginning, right there, and right there. Or you can do it in your answer. Since you've already done f plus g of x, you can do it right here. And I'll show you that they equal the same thing. So if I plug it into this one, I would have 4, because that's f plus g. So if I plug it in right here, I have 4 times, and then instead of x, you put 3. And then I would have 12 plus 2, which is 14. Now if I choose to do it this way, I could go, the other way is I could put 3 in at the beginning. So I could find f of 3, which is 3 plus 3, which is 6. And I could find g of 3, which is 3 times 3 minus 1. So 9 subtract 1, so 8. Then, if I want f plus g of 3, I just take 6 plus 8. And guess what? 6 plus 8 is 14, just like we figured up right there. So whichever way you like it best, you can do. So that's the algebra of functions. And of course, the last one would be divide. And typically, if I were going to do that one, I'll do that last one, f divided by g of x. And by the way, you say f of g of x, which just means that the variable is x. It doesn't mean multiply. Those parentheses aren't multiplication. They just mean f of g of x means the variable is x. So, plugging that in, I go to my f, my function right here, and that's on top, divided by g, which is 3x minus 1. And that's all they expect you to do. You don't have to do long division. If there was obvious simplification, you would do it. But you know to simplify, it has to be in all 4 terms. So don't cross out x's, don't cross out 3's. You can't simplify unless you can take it out of everything. So you're done. All right, the other question was composite functions. So let's say that I give you a function f, and again we'll call it g. And that's always given. So they give you f and they give you g. Then they will say find, and it looks like this. F, and instead of a dot, it's a hollow little circle. F of g, and again they tell you the variable of x. What that means, some kids tell me that it's easiest for them to think of going backwards, going left to right, because you plug x into g, and then you plug that answer into f. Once again, I'm going to show you how they used to write it. They used to write it like this, which again I think makes a little more sense because you can clearly see that you're plugging g into f. And what's nice about it is, look, the order stays exactly the same. So if it's easier for you to switch it to that, you can. Or just go left to right. So if I'm plugging x into g, I already have that. That was how it was given. G of x is x plus 1. So now I need to plug all of this whole thing, into f, wherever I see x. So f of g of x just means I go to function f first, and instead of x, I plug in the whole function g of x. So I have the square root of x plus 1. Now if they said f of g of 3, for example, then I have already done f of g of x, so I could just plug it into that right there. And I would have 3 plus 1 equals the square root of 4, which we know is 2. Or the other way to do it is to go ahead and think of plugging 3 into g first. So I'm going to go over here to function g and plug 3 in. So g of 3 is 3 plus 1, which is 4. And then I'm going to plug that into f. So I take 4 and plug it into f. So f of 4 is the square root of 4, which is 2. So you have both of those methods, which are good methods. Let me do that one more time in case that's not solid yet. So let's use those same functions and do them another way. So let's say f of x is the square root of x, g of x is x plus 1. So now let's do g of f of x. Okay, so now I'm going to plug x into f, and I come up here and go, oh, that's what's in f already, so it's done. And then I'm going to plug that into g. So now I go to g, or some people go, oh, g is first, so go to g. But instead of x, you're going to put in f of x. And f of x is this whole function right here. So I'm plugging that into that x right there. So I have then the square root of x, and I still have this plus 1, which is not in the square root now. Okay, so let's do g of f of 9. So again, since I already have g of f of x, I can just plug it in right there and go, oh, the square root of 9 plus 1 is 3 plus 1, or 4. The other way to do it is to take 9 and plug it into f. So I'm going to come up here and take f of 9. And I have the square root of 9, which is 3. And then I'm going to plug that into g. So then I come over here and say, well, g of 3, here's my g, is 3 plus 1, which is 4. And look, we end up with the same thing, whichever way you like it better. Let's do one more. So suppose I give you f of x is x squared, and g of x is x plus 1. Oh wait, sorry, that was that problem. G of x is 2x plus 1. Okay, let's go ahead and find f of g of x. So, once again, I'm going to take g of x and plug it into g. That's already there. And then I'm going to plug that into f. Or the other way to think of it is, okay, I see f first, so I'm going to go to f, and wherever I see x, I'm going to plug in g of x. So instead of this x right here, I have this whole thing. I have 2x plus 1, and that whole thing is squared. And that's it. Now they might go ahead and FOIL that, because we know that means this whole thing times itself. So I have 4x squared, outside times the outside, inside times the inside, last times the last. So that is our answer. That is f of g of x, that whole equation. Let's do g of f of x. So now I go to function g first, and instead of x, what do I plug in? F of x. So f of x is x squared, so I'm going to plug that in right here for this x. So I have 2, but then instead of x, I'm going to put f of x, which is x squared. And then I continue it, plus 1. Done. That's done. Now they could make it a tinge bit harder by giving you a variable. Let's do f of g of 3. So once again, there's two ways to do it. I already have f of g of x right here, so I can just plug it into that if I want. So I would have 4 times 3 squared plus 4 times 3 plus 1. Just plugging 3 in to all the x's. So I would have 4, remember that you square first before you multiply, so I have 4 times 9 plus 12 plus 1, or 36 plus 12 plus 1. So I have, let's see, 36, 48, 49, right? And the other way to do it, if you like this method better, is that you take 3 and plug it into g. So I come up here to g, and I take g of 3. So I have 2 times 3 plus 1. So we know that that is 6 plus 1, or 7. And now you plug that into f. So working left to right, now I plug that answer into f. So I come down here and take f of the answer I just found, 7. So plugging that in right here, because that's my f of x, I'm plugging it in right there, I get 7 squared, which is 49. And so if you're not sure, try to do it both ways and make sure you get the same answer, and then you know you'll be right on your test. Good luck, you guys. Hang in there.